I love to cook. That's something that I always loved since I was a teenager. When you merge different flavors, you get something which is completely new, that is really exciting. That's somehow what happened, I believe, for me in science.
Alessandro Vespignani is one of the first to put the new understanding of networks to practical use, and his findings could save millions of lives. His specialty is diffusion, what happens when things mix together, whether it's a cream sauce or the way a computer virus spreads through the internet. In 2000, the I Love You virus spread around the globe in just hours.
And penetrated the CIA, the Pentagon and the Houses of Parliament.
Vespignani was puzzled by its rapid spread and by its resilience. Even though software to kill the bug was released within a day, it survived for months.
Japan came back from a week-long holiday to find a love bug still lurking in many people's computers.
The quicker is the disease at the beginning, and the quicker it should die out from the system. And actually this was not the case. We were really puzzled by this fact that the I Love You virus was lingering in the wild.
Like other scientists, Vespignani assumed that viruses spread at random.
We were, trying a few things, and actually something at a certain point I was struck by a paper.
It was Barabashi's study showing the internet had a predictable structure.
When I saw that image of the internet, I thought that that was the pattern that I had to include in the model in order to get a realistic description of what was happening with computer viruses.
By mixing his knowledge of diffusion with the new map of the internet, he discovered that I Love You could move unstoppably through the hubs and hide in the far reaches of the net. And as he was about to learn, this had alarming implications.
Chamberlain, nearly 7 feet...
Champion basketballer Wilt Chamberlain claimed he'd had sex with 20,000 women, an exhausting average of 1.9 couplings per day over his adult life.
Wilt was almost unstoppable.
Even allowing for some exaggeration, he was clearly a hub in the human sexual network.
There are few records left for Wilt to tilt.
At first, Vespignani didn't believe that people like Chamberlain had implications for the spread of disease.
No way, it was clearly not applicable in my mind, because the internet is different from the web of sexual relation. I was wrong.
A Swedish study of sexual behavior showed most people had only a few partners, but a handful had hundreds. The web of sexual relations looked exactly like the internet. It was dominated by a few hubs. And just like I Love You, this meant that if a virus entered the network, it would be almost impossible to remove.
So suddenly, from one day to another, what we were doing in the computer virus area was important for human diseases.
Vespignani's research helps explain the resilience of HIV. Despite 2 decades and billions of dollars in prevention programs, the virus is entering an explosive new era of growth. Awareness campaigns like this controversial Australian ad of the 1980s are doomed to failure. No program aimed solely at the general public will work. Ignore the hubs and the virus will never be beaten. Vespignani's group is now modelling the intersection of global transport networks and disease. They can predict the spread of a new flu virus. Airline networks are dominated by a few major airports. Once an infected person passes through one of these hubs, the virus will be unstoppable. But Vespignani's research also offers a solution. The way to prevent a global catastrophe is by sharing precious antivirals.
What you find is that it's beneficial to the entire world and to each country to share antivirals, to be cooperative and not to be selfish. We form a global network, and whatever we do is going to reverberate across the network and have important implications at the global level.
Understanding 6 degrees may be the planet's best hope of dealing with some of our most complex problems.
West Point, 200 years uninterrupted by progress.
The predictive power of networks is attracting intense interest and changing some old ways of thinking. Faced with a new kind of war, the US Military Academy is teaching a new generation of officers the power of network science.
You're not dealing with who has the better guns in this case, but you're dealing with how do we pick out these people, how are they linked, and how can we disrupt them? And that is, at its core, a network science problem.
Is there one node that sticks out at you that we would want to remove? The center node. How come? So it's got the most connections. That's right.
We can take a network of different terrorists and how they interact with each other and how they link up, and from that we can determine who the key leaders are in these groups and who it is we need to target in order to break up these cells and prevent further terrorist activity.
The first application of this new paradigm is also the most spectacular. Network science principles led directly to the capture of Saddam Hussein.
Ladies and gentlemen, we got him.
The way we were able to capture Saddam Hussein was not through his utilizing cell phones or any type of communication device, but the social network structure of family and supporters that existed. We were able to identify the particular nodes of communication amongst those individuals, what they were saying, and based on that and the location, we were able to pinpoint where he was.
Understanding and applying network science will revolutionize battlefield tactics.
I believe network science is going to benefit the military immensely. And the reason why is because we'll be able to predict behavior unlike any time before.
The first generation of network-trained officers is already on the battlefield. It's been less than a decade since the ideas they now trust with their lives were first discovered. From Burma to Germany to America, one package is making swift progress.
Are you Mr. Thomas?
Yes, I am.
I have a delivery for you.
Thank you. I wonder what it is. It's a letter about that old paradigm, 6 degrees of separation.
What's the final destination?
The final destination is this geneticist at Harvard by the name of Mark Vidal. But I know somebody at Harvard that I can mail this to. It's Michael Miller. He's a psychiatrist.
Perfect.
Editor-in-chief of the Harvard Mental Health Letter. I figure he either knows Dr. Vidal or knows somebody who knows Dr. Vidal.
Mark Vidal is a geneticist. For him, the 6 degrees experiment is part of a much greater project, creating the first roadmap of the human cell.
Imagine if we try to understand traffic in a city without having any maps, without having any idea of how interconnected the different roads are. Analogies are never perfect, but it's one way that I can imagine how things occur in the cell.
Cells are the building blocks of life and hold the genes that determine our development. Those genetic instructions are carried out by thousands of different proteins, the worker bees of the cell.
The proteins are the little tools, the parts of the cell. They don't work in isolation. They interact with each other.
In Vidal's bustling cellular city, proteins are like people, constantly on the move and communicating with one another.
If I start from my favorite protein and I ask, what does it interact with? I'm now back to basically a problem of 6 degrees of separation. Who is connected to whom?
Vidal believes that if he could produce a map, then potentially he could locate breakdowns in the system that cause disease. Diseases like cancer, where the genetic signal to kill a cell has been lost.
And so I devoted my life to trying to understand the interconnectivity between genes.
Mark Vidal goes to every single molecule and say, whom do you interact with? Now it goes to those molecules and say, whom do you interact with? And step by step generates us a network of the cell in the same way that in 1999 we created a map of the World Wide Web. He did not know about us. I had no idea about him. Everybody thought he's crazy.
The vast majority of biologists would have thought that even if we had a good quality map of the wiring diagram of the cell, not much really interesting would emerge out of it.
Vidal's theory may have come to nothing had he not stumbled upon the work of another scientist. It was Barabashi's paper describing a universal law in networks.
And this really was an eye-opener. What became immediately obvious to me when I opened that magazine, it would be incredible if we could actually use it in the context of cellular networks and try to use similar models to explain human disease.
Seeing disease as a network means it's no longer just about biology. It's become a maths problem. And this offers entirely new ways of dealing with disease, so promising that Laszlo Barabashi has joined forces with Vidal to explore the potential.
One day, Laszlo came to my office all excited, saying, what if we looked at all the connections at the same time for all diseases and all genes involved in diseases?
The result is the most remarkable network map of all. It shows for the first time connections between every known human disease. And just as the Hollywood Actors Network linked stars through their films, we can now see how diseases are linked by the genes they have in common.
The network that came out of this analysis had absolutely incredible properties. For one thing, in many diseases, we still don't know all the genes that are involved in those diseases. Breast cancer is one example of that. And so using maps such as that one, that can help us finding the genes that have remained a mystery up until now.
Laurie Benson is a young mother fighting breast cancer. It's already claimed the lives of 2 women in her family. Science has only identified 10% of the genes responsible for breast cancers, and that severely limits the effectiveness of treatments.
I was 38. My daughter was 14 months old. And from the day that I found out to the day I went into surgery was only 10 days.
With a daughter who may also be carrying the faulty genes responsible for the disease, she's keen to know more. Vidal's research could offer a dramatic shortcut to finding the root cause of the disease.
Hi, nice to meet you.
Very nice to see you. How was your trip?
Very good.
Yeah, come in, please. Anyway, so what I want to show you here, we use yeast cells, which you can actually see on this photo here.
Vidal places human proteins into yeast cells and then waits to see which ones interact with each other.
So the ones that don't have any growth, that means they're not connected?
Exactly. Okay. Of course, this is a very small experiment, and you have to imagine hundreds and thousands of plates like this one, which then allow us to say, those pairs do not interact, those pairs they do. Let's draw the network, let's study it, and let's try to extract biological information from that.
Okay. How is it going to be actually applied to treating people?
The effect of a drug might be very different in one individual relative to another one, considering the nature and the properties of this big network over here.
And to individualize the treatment.
And individualize, personalize.
Okay.
That's certainly the hope.
Vidal's work remains experimental, but his network maps may be the best hope for future generations of Laurie's family. From Hollywood to maths equation to a daring new approach to fighting disease, this is the promise of network science, a new way of seeing our world. The first package has made it to Boston, reaching a work colleague of Mark Vidal.
Let me run inside and get that package for you.
Okay. Thank you very much.
You're
I'll
welcome.
sure deliver it.
All right, great.
Thank you.
Great. See you next time.
Mark and I serve on some committees together, and I've advised him on a couple of legal matters over the years. He's in the building right next door to me, and I can deliver this package to him quite easily.
Hello. I have a package for Mark Vidal.
Is Mark in?
He is, but while you're walking over there, would you please pass that on to him?
No problem. Hi, Mark.
Right.
Oops, sorry.
Hey, Basil, how are you?
Hey, good to see you.
Good to see you.
There is something for you.
Let's see the story with this one.
All right, let's see what you got here.
Okay, so...
This package has traveled more than 10,000 kilometers.
So this is a lady called Nyaloka Oma.
Okay.
We went from a small town in Kenya all the way to Boston. 2, 3, 4, 5, 6. Six
There
degrees
you
of
are.
separation.
There you are.
Perfect.
6 degrees is not just an urban myth after all. In a few short steps, we've gone from crickets to Kevin Bacon to cancer. A decade on, Bacon has decided he might as well accept his cult status.
When I first heard about the 6 Degrees of Kevin Bacon game, I was really kind of horrified. I thought it was a joke at my expense. And I was hoping that it would go the way of pet rocks and 8-track cassette tapes, but it seems to be hanging on.
Now he's put the power of social networking to good use, launching a charity website, 6degrees.org. The site lets people like Laurie Benson link her friends and their friends to good causes like Mark Vidal's work at Dana-Farber.
I want to make a plea that we use the power of 6 Degrees and social networks and make a donation to Vidal's lab. To me, his work sounds like our greatest hope for finding a cure.
Our packages have passed through 28 countries and 53 cities. 3 chains made it to Mark Vidal, and they averaged 6 steps in getting there. 6 Degrees has revealed a new view of nature and a reminder that if the world is small, then we're all in this together.
Everything appears to be connected in ways that, were absolutely not predictable just 10 years ago or even 5 years ago.
It's going to completely change the way we think about the world.
All the major problems in science today depend on understanding networks.
Network science is the foundation of the 21st century.